Here we have some problems about different ways to display data. We've looked at histograms already and some different kinds of bar graphs, but there are a lot of different ways to display the results from a survey or to display a set of numbers, and it's good to get familiar with a few of those. Let's look at this first one here. I know the writing is a little bit small. The question says the table below shows the number of sandwiches sold at a school during 1 week. How many more tuna salad sandwiches were sold than fish burger salad sandwiches? So we got fish burgers, ginger chicken, roasted veggie, tuna salad, and turkey meatball. They want us to look at tuna salad and fish burger and say how many more tuna salad were sold. And then we've got these marks here. Well, luckily there's a key down below, and this is really important. It has this sort of 2 square brackets equals 60 sandwiches. So those 2 square brackets together kind of look like a sandwich, and each one of those represents 60 sandwiches sold. So let's look at fish burger and try to convert this into numbers. There's 1, 2, 3, 4, and oh, this one looks like a half a one. So 4.5 of these. If each one equals 60, it'd be 60, 120, 180, 240, and then half of that would be another 30. So that would be 270 fish burger sandwiches. Sounds good. And then the tuna salad, we've got 1, 2, 3, 4, 5, 6, 7, 8. That's going to be, if you can plug that into your calculator, but I think that's going to be 480 tuna salad sandwiches sold. So how many more tuna salad were sold? Well, let's just subtract 480 minus 270, 210 more sandwiches. So part of this that's important is just realizing that there was a key there that would tell us the secret for deciphering the way they've displayed the data. All right, let's look at this next one. This is a pretty common kind of problem. It says, which of the following shows the correct line plot and median for the set of data? And then they give this jumble of numbers. Well, we need to know a couple of things. We need to know how they do this line plot. We need to know what a median is. And then we need to really have a good grasp on this data set. The first thing that I usually like to do when I'm given just a jumble of numbers like this is put them in order. So these are all mixed up. I'm going to start with the lowest and put them in order. So 31, I'm just going to mark them off when I get them. Are there any 32s? There's one. Oh, there's another. And another. And then let's see, we've got a 33. Oh, and another 33. And then we've got a 34. And a 36. And we've got 2 39s. Okay, there's the whole data set. I don't think I ran off the edge of the screen. No. In order. Now the median of this data set is going to be the number that's in the middle. So we count off the same from either end and pick what's in the middle. Actually, let me just count the number of pieces of data here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I count off 4 from this side, 1, 2, 3, 4, I'm going to make a line there, and then 4 from this side, 1, 2, 3, 4, I get the 2 middle ones. Sometimes if it's an odd number, it'll just be one middle one, and you know for sure that's the median. If you have 2 numbers in the middle, because it's an even set, then if the numbers are the same, well, that number is the median. If the numbers aren't the same, you have to take the average of them. In this case, they're the same, 33. So 33 is definitely the median, the middle number when you've got the set lined up in order. Now, the only other thing to do is understand how this line plot works. You can see they've got, it looks like a regular number line. They've got 30, 35, 40. All our numbers are between 30 and 40. And then this would be 31, 32, 33, 34, 35, 36, etc. And then anytime that number appears, you put an X above it. So we've got 131, there's the X for 31. We've got 332, so X, 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 etc. If you look at these number lines in the answer choices, we're supposed to pick the right one. They're both the same, and they're both right. 2 39s, 136, a 34, 3 32s. Actually, no, this one's right, not right. That's 3 33s. So there's an error there. It should have been 3 32s. The other clue here is that it's got the median, and we figured that 33 was the median. So it looks like choice A is the right answer there. All right, we're going to look at one more way of representing data here, and this is some pretty tricky stuff. This is a frequency table, but it's got an added column here. It's got languages that students are enrolling in a school, and then the frequency, that would be how many students are enrolled in each language, and then the relative frequency. They get a relative frequency by taking the number of students in a language and dividing it by the total. So you can see here, the frequency table shows below the enrollment of 808 students. If 143 are in French, so I can take 143 divided by 808, I'm using my calculator now, and I get a 0.18 as a frequency. So this number here is just that number divided by the total. Now here's where the problem gets a little complicated. It says the school estimates that its enrollment will increase next year to 949 because of the construction of a new housing development within 1 mile of the school. Use the frequency table to estimate the number of students expected to take Spanish after the increase in enrollment takes place. So the old enrollment was 808. The new enrollment is 949. And assuming, you know, these ratios, these numbers stay about the same proportion of students want Spanish or Russian or German. The question is, what's this new number going to be? So the thing we have to do here is actually use our relative frequency. You can also even think of this as a percent. If you move that decimal place, point 2 places to the right, you get 16% here. And what this is really saying is that 16% of the students like to take Spanish. To figure out if we increase our enrollment and kept that percentage the same, how many students would there be that next year? What we need to do is take 16% of 949. Of means multiply, so we're actually going to multiply, and I would convert this to a percent, but I'd have to convert it right back again to do my multiplying. It's going to be 949 times 0.16. So I'm going to plug that into my calculator, and I get 151.84, so we'll round that up to 152. And there's our new group of Spanish students for next year. So those are some different ways to display data.